Welcome to graphing 7 curves using the over, up, down table. When you have finished these 4 videos, you should realize that whatever happens to one of these curves is the same as what happens to all of them, and you'll be able to do a lot of different things with these 7 curves. So the first curve is really not a curve, it's a linear equation, and it's just y equals x. So we call this a linear equation. You'll see why in a few minutes. Each time I'm going to go over, which is in the x direction, and up or down, which is in the y direction. So if y equals x, if I go over 1, I'm going to go up 1. If I go over 2, I'm going to go up 2. If I go over to the right 3, I'm going to go up 3. If I go over 0, I'm going to go up 0. If I go to the left 1, I'm going to go down 1. If I go to the left 2, I'll go down 2. If I go to the left 3, I'll go down 3. Plotting this, if I go over 1, I go up 1. Over 2, up 2. Over 3, up 3. Over 0, up 0. To the left 1, down 1. To the left 2, down 2. To the left 3, down 3. And what you end up with, as you can see, is a straight line. So that's why it's called a linear curve. Now the next curve we're going to look at is we're going to bring in the absolute value sign. So this is called absolute value. What it does is make everything positive. So if I go to the right 1, I'm going to go up the absolute value of 1, which equals 1. If I go to the right 2, I'll go up the absolute value of 2, which equals 2. If I go up 3, I'll go up over the absolute value of 3, which equals 3. If I go over 0, I'm going to go up the absolute value of 0, which equals 0. But now things are going to change. If I go to the left 1, I'm going to go up the absolute value of negative 1, which is positive 1. I'm still going to go up. If I go to the left 2, I'm going to go up the absolute value of negative 2, which is 2. If I go to the left 3, I'll go up the absolute value of negative 3, which is 3. And this is what happens. When I graph it, if I go over 1, I go up 1. Over 2, up 2. Over 3, up 3. Over 0, up 0. To the left 1, I still go up. To the left 2, I still go up. To the left 3, I still go up. And what you end up with is sort of a V shape at a 45-degree angle for this particular equation. So an absolute value looks like that. The third graph I'm going to do is y equals x squared. And this is just what we call a quadratic. So if I go over 1, I'm going to go up 1 squared, which is 1. If I go over 2, I'll go up 2 squared, which is 4. If I go over 3, I'll go up 3 squared, which is 9. If I go over 0, I'll go up 0 squared, which is 0. If I go to the left 1, I'm going to go up negative 1 all squared, which is up 1. Negative 2 all squared is going to be up 4. And if I go to the left 3, I'm going to go up negative 3 all squared, which is up 9. So what you get here when you plot it is if I go over 1, I go up 1. If I go over 2, I go up 4. If I go over 3, I go up 9. And over 4, of course, I go up 16. If I go over 0, I go up 0. Left 1, I still go up 1. Left 2, I go up 4. Left 3, I go up 9. Left 4, of course, I go up 16. And when you graph this, you get what we call a parabola. You get a nice curve looking like that. Okay. Now the fourth set of equations I'm going to use is going to be y equals x cubed. And That's called a cubic equation. It works exactly the same way as the others, except when I go over 1, I'm going to go up 1 cubed, which is 1. If I go over 2, I'll go up 2 cubed, which is 8. If I go over 3, I'm going to go up 3 cubed, which is 27. If I go over 0, I'm going to go up 0 cubed, which is 0. If I go to the left, I'm going to go over negative 1 to the left. I'm going to go down because negative 1 cubed is negative 1. Negative 2 cubed, if I go 2 to the left, is negative 8. And negative 3 cubed is negative 27. So when you graph this, if I go over 1, I go up 1. If I go over 2, I go up 8. If I go over 3, I go up 27. If I go over 4, I go up 4 cubed, which is 64. Over 0, I go up 0. Left 1, I go down 1. Left 2, I go down 8. Left 3, I go down 27. Left 4, I go down 64. And we get a shape looking like this. Y equals the square root of x. So these are our square roots. This time on my over-up table, I'm going to go over 1, and then I go up the square root of 1, which is 1. And instead of working at the square root of 2 and 3, I'm going to go over 4, because it has a perfect square root. Then I'm going to go up 2. And I'll go over 9, and its square root is 3. And if I go up 0, the square root of 0 is up 0. If I go to the left one, the square root of negative 1 is a no-no. Okay, it doesn't exist in real numbers, so we won't plot it. So anything in the negatives isn't going to get plotted. So if I go over 1, I go up 1. Sorry, if I go over 4, I'm going to go up 2. If I go over 9, I'm going to go up 3. And if I go over 0, I'll go up 0. Ignore this one, I made a mistake there. This graph's like that. The sixth curve that we're going to look at is what we call an exponential curve. You've probably heard the phrase exponential growth, and you'll see why we do that. This is 2 to the power x. So if I go over 1, which is my x value, I'm going to go up 2 to the power 1, which is 2. But if I go over 2, I'm going to go up 2 to the power 2, which is 4. And if I go over 3, I'm going to go up 2 to the power 3, which is 8. Now if I go over 0, I'm going to go up 2 to the power 0, which is 1. So you'll see in a few seconds something slightly different about this graph. If I go over negative 1, I go up 2 to the power negative 1, which is a half. If I go over negative 2, I'm going to go up 2 to the power negative 2, which is a quarter. And if I go up left 3, I'm going to go up 2 to the power negative 3, which is 1/8. So when you graph this, over 1, I go up 2. Over 2, I go up 4. Over 3, I go up 8. Over 0, I go up 1. So it actually doesn't go through what we call the starting point. Think of all of these curves of having a starting point at 0, 0. Now if I go to the left one, I'm going to go up a half. If I go to the left 2, I'm going to go up a quarter. And if I go to the left 3, I go up an 1/8, and left 4, I go up a 1/16, and so on. So this graph looks like this. It comes through here, it cuts through one above my starting point, and then it gets closer and closer to this line here. but never touches. We call that an asymptote. Okay. Now the last graph to look at. This is y equals 1 over x, and this is called a reciprocal. If I go over 1, I'm going to go up 1 over 1. If I go over the right 2, I'm going to go up 1 over 2, which is a half. If I go over 3, I'm going to go up 1 over 3, which is a third. If I go over 0, I'm going to go over 1 over 0, which is a no-no. Cannot divide by 0. Left a half, I'm going to go up 1 over a half, which is 2. Left a third, 1 over a third, which is 3. Sorry, not left, these are right. These are positive numbers. Go to the right 1/4, I'm going to go up 1 over a quarter, which is 4. Now when you graph these, the first one is there. If I go over 2, I go up a half. If I go over 3, I go up a third. Over 4, I go up a fourth, etc. Over 0, there's no value. Okay, if I go over a half, I'm going to go up 2. If I go over a third, I'm going to go up 3. If I go to the right a quarter, I'm going to go up 4. So this curve is asymptotic to the y-axis, curves around here, and it becomes asymptotic to the x-axis over here. Now the same thing works if you put in a negative sign and go to the left for each one of these. Then what's going to happen is if you go to the left 1, you're going to go down 1. Left 2, you go down a half. Left 3, you go down a third. Left 4, you go down a fourth. Left a half, you go down 2. Left a third, you go down 3. Left a fourth, you go down 4. So you get another side to the equation that looks like this. It comes in on this side here. So you get a curve that looks like that. And that's graphing the basic 7 curves. Now the next 2 videos will play themes and variations on these and see what we can do with these.